We want to look at continuous random variables and the concept of point probabilities. Now, continuous random variables take a continuum of values or uncountably infinite number of values. Their possible values form a continuous interval, such as the interval 0, 1, instead of a list. So there are an uncountable number of elements in this interval. So for a continuous random variable, we have an uncountably infinite number of values that take the form of an interval, and within this interval, we have an uncountable number of elements. Now, for any continuous random variable x, the probability that x, capital X, the random variable capital X takes the value small x is 0. Because remember, uppercase letters are used for random variable, lowercase letters are used to represent its values. So here probability capital X is equal to small x is the probability the continuous random variable capital X is taking a specific value small x. This is what we can call a point probability. The probability the continuous random variable takes a specific value. For any continuous random variable x, the probability that it takes any specific value is always 0. Now, why is that? Like we said, continuous random variable takes a continuum of values. It takes countably infinite values that form this interval where there are an uncountable number of elements. So now, because there is such a continuum of values, the chances of any one point are so low that almost become equal to 0. So point probabilities in the case of continuous random variable are 0, but we do have point probabilities for discrete random variable, where we know it takes finite values, accountably finite values. In that case, we do have probabilities that the discrete random variable takes a specific value. So also an important distinction between them is for continuous random variable, the probability takes a specific value 0, but for discrete random variable, the probability that it takes a specific value is not always 0. You do have point probability specified in the PMF. Now, what are the implications of this fact that for a continuous random variable, the probability takes a specific value is always 0? Now, we're going to discuss two implications. The first is that when we're solving for probabilities involving continuous random variable, the equal to sign does not matter because the probability takes a specific value is always 0, right? The fact that it takes a specific value, the probability of that is 0. So when you're finding probabilities for continuous random variable, it doesn't matter whether you have or don't have an equal to sign. So for a continuous random variable x, whether I talk about probability x is greater than a or x is greater than equal to a, they're the same thing, right? So whether it's probability x is greater than a or x is greater than equal to a, it doesn't matter how you write it, it's the same thing because the probability that x is a is just 0. Similarly, probability x is less than a or probability x less than equal to a is the same thing as probability x is a is 0. Probability x is greater than equal to a less than equal to b, or probability x is greater than a, x is greater than b, sorry, x is greater than a less than b, or probability x is greater than equal to a less than b, or probability x is greater than a less than equal to b. Again, all four of these are the same thing because the probability that x is equal to a is equal to 0, and so is the probability x is equal to b. So for a continuous random variable, the fact that the probability it takes a specific value is always 0. So it doesn't matter whether when you're finding probabilities of continuous random variable, whether you put an equal to sign or not, it's irrelevant. So for continuous random variable, it doesn't matter whether you write less than or less than equal to, greater or greater than equal to, the equal to sign does not matter. But like we said, for discrete random variable, the probability takes a specific value. The point probabilities do exist, i.e. the probabilities that it takes a specific value. So for the equal to sign does matter for a discrete random variable. So for discrete random variable, we are concerned with do we have a less than or less than equal to, greater than or greater than equal to, right? So the equal to sign here for a discrete random variable does matter because x less than equal to 3 would mean you won't include, you will include 3, x less than 3 means you won't include 3. For a continuous random variable, it doesn't matter whether you write an equal to sign or not when finding probabilities, but for discrete random variable, it makes a lot of difference whether it's less than or less than equal to. Similarly, whether it's greater than or greater than equal to. So the first implication is that it doesn't matter whether you have an equal to sign or not when you're finding probabilities for continuous random variable. The second implication of the fact that point probabilities for a continuous random variable are 0 is that we never talk about point probabilities for continuous random variable. Again, point probabilities, the probability takes a specific value because those probabilities are always 0. So we always find the probability the continuous random variable lies in an interval or range. So for a continuous random variable, point probabilities are 0, i.e. the probability that it takes a specific value. So there are two implications of this. Number one, when you're finding the probability, when you're finding probabilities involving a continuous random variable, it doesn't matter whether you have an equal to sign or not. Second, we will never talk about point probabilities for continuous random variable because like we said, they're always 0. Rather, we will talk about the probability that the continuous random variable lies in some interval or range. So when you look at questions related to continuous random variable, you'll always find that they're never asking you the probability the continuous random variable is equal to a specific value because that is equal to 0. They will always ask the probability the continuous random variable lies in some interval.